everyone. My name is Abhinay Bidua, and the topic for the special assignment I have chosen is Micro C OS. So I am basically going to tell about the version 2 of it. So the introduction part, Micro C OS stands for Microcontroller Operating System, and it is a priority-based real-time scheduling policy, and it is mainly written in the C programming language. It is intended for use in embedded systems, and most of the embedded systems available in market are using this OS. And currently, the licensing of this OS is done by the Micrium company. So it is basically the owner of this OS, and all the rights has been given by this. So if you have to purchase this, you have to contact them. So let me talk about the history. J&J Labros was working on an Intel-based product for which he required a real-time kernel. So he went on the market and searched for many available kernels, but they were costly and slow. So in its application, does not fit. So he decided to build his own kernel. It took him about a year for the same, and he was successful in building his own kernel and named it Microc OS. His work was published in the Embedded System Programming magazine, and he further went on to write books and till now has three versions for the same. Many research scholars are using these books for the reference materials. So now the features of Microc OS. It is a very small real-time kernel. The footprint is about 20 KB, so it is very compact in size. It is mostly written in NCC, so it is highly portable, roamable, very scalable, deterministic, multitasking, and so on. So these are the features of it. It can manage up to 64 tasks. Out of them, 8 tasks are reserved for the system use, whereas 56 tasks are available for the user. It has connectivity with GUI and file systems. It has ported to more than 100 microprocessors and microcontrollers. It is simple to use, implement, but very effective compared to the price performance ratio. It supports all type of processors from 8-bit to 64-bit. So it is very useful feature when interfacing with different microprocessors. Task states. MicroCOS has 5 different tasks for making it is a multitasking operating system. The states are the dormant state, ready state, running state, waiting state, and ISR states. So this is basically the relationship between the task. So let me explain each task. The dormant state corresponds to a task which resides in program space but has not been made available to the MUSI OS version. A task is made available by calling either the OS task create or the OS task create external function. So then it can be into the ready state. Multitasking is started by calling the OS start functions. So we get the illusion that the all tasks are running parallelly, but only one task are running actually. The running task may delay itself by getting into the waiting state by the help of the signals like the OS time delay, then some arguments like the hour, minute, seconds, and milliseconds. These are the extra features. Once we are in the running state, it can be interrupted by some interrupts using the interrupt signal, and it can return back to the OS exit signal back to the running state. So, running text can always be interrupted. So this is basically the idea. When all tasks are either waiting for events or for time to expire, then MusiOS executes the ideal state function. So means the CPU is in the ideal state. So this is basically the relationship between the states. For the task management services, MusiOS has the following features like the task creation, task check and checking mechanism, task deletion mechanism, change a task priority, suspend and resume a task, get information about a particular task, and so on. So for the task creation, it has the task create function, the task create external functions. The task has been created, it requires a stack. So for that, we require a continuous memory location. So it is helpful in that. Also in deleting a task, it does not mean that we are actually deleting the code, but it is just changing its state to the dormant state. To delete itself, the task has to itself left the resources. So this is basically the task delete mechanism. Now the time management. That for time management, MusiOS has a clock tick timer for which it varies from 10 to 100 millisecond. The faster the time rate, the higher the overhead will be imposed on the system. So we have to choose the time tick accordingly between this range, that is 10 to 100 millisecond. And whenever a time clock occurs, Museos increments the 32-bit counter, which starts from 0 and rolls over to this value, which is 2 raised to 32 minus 1 ticks. A task can delete and delayed task can also be resumed. So this is a vice versa process. For the time management, it has the following five functions. That is the delay function that delay with some argument and the delay resume and getting the time of delay and setting the time of delay to a particular value. For inter-task communication, we have the following three important things in MuseOS like the semaphores, message mailbox, and message queues. Task and interrupts can service routine ISRs. Means they can interact using the ECB. Event control block is an important thing in the MuseOS. For the single task waiting, the task can get the service by using the ECB by the wait and the signal, and this is how process communication can happen in a single task waiting. For the multiple task waiting, they have to generate signal and the wait signal, and contact is done using the event control block. Task can wait and signal along with an optimal timeout. Means the timeout facility is also being provided in the MuseOS. For semaphores in MuseOS, we have the two elements, that is the 16-bit integer counter and list of tasks waiting for semaphores. For that, we have to create signals like the SAM pend signal, SAM accept signal, SAM query signals. So MuseOS provides the create, post, pend, accept like these services. So this is basically the semaphore way of interprocess communication. The message bulb box allows a task or ISA to send a pointer sized variable to another task. So this is another type of process communication. So this is the required signal which has to be which has to be established for communication. In message queues, in message queues we have the functionalities like the FIFO, PIPO, LIFO, and so on. And this is basically in this also we have to generate the required signals like the pend, accept, and the query signals. And this is another way of communication available in the MuseOS. Now I have compared the MuseOS with its upgraded version, that is the MuseOS 3. So the release date of the MuseOS 2 is around 1999 and the of version 3 is 2009. Both are currently being used, and MuseOS is basically the upgraded version of MuseOS 2. So the maximum number of tasks in version 2 is limited to 255, where it is unlimited in version 3. The round robin scheduling has been added into the version 3 while it is in lacking in version 2. So as you can see, most of the things is just upgraded thing and added features in the versions 3. So now I have compared it with the FreeRTOS. FreeRTOS is another type of real-time operating system available in the market, which is widely used in the embedded system domain. And in the comparison of MuseOS is basically it is simpler in comparison with the FreeRTOS. FreeRTOS only supports queue, semaphores, mutex, while the MuseOS besides that also supports flag and mailbox. In addition to the operating system, FreeRTOS only supports TCP/IP, whereas MuseOS also supports file system, USB, GUI, CAN, along with the TCP/IP. And MuseOS is more reliable, and also we have seen that the footprint is only 20 KB, so it is more optimized in compared to the FreeRTOS. So these are the references I have considered. The first one is the real-time kernel book by the J. Labros. The second is another book by the Bowett and Daniel. The third and fourth references are from the Micrium official site, and the fifth is a research paper from the School of Electrical and Computer Engineering, Cornell University. So now it is the end of my presentation. So now let me switch to the present hands-on work which I have done. So I have implemented the rate monitoring scheduling in Python. So what is rate monitoring scheduling? So it is the priority algorithm that belongs to the static priority scheduling category. So for setting up the task, we have we have to satisfy the following condition. The here n is basically the number of processes in the process set, c is the computation time, t is the time period, and u is the utilization factor. So let us illustrate this with the help of an example. Suppose there are three tasks T0, T1, T2 with the following execution time and the time period. We calculate first the setting time, so it is coming out to be 0.79, and then the utilization factor, which is coming out to be 0.75. Since the utilization factor is less than the setting time, our algorithm can schedule these processes. So for doing the scheduling, we have to consider two steps. That is, the first is the finding the scheduling time and assigning the priority. For finding the scheduling time, we have to take the LCM of the periods of the given task. So here, as you can see that the periods are 25 and 10. So LCM of them is 20. And since the T1 has the minimum time for execution, so it has the highest priority. So it is basically the lesser the time period, more is the priority. So T1 has the higher priority than T2, T2 has higher priority than T0. So this is basically the scheduling algorithm. And from the 20 units, T0 has to execute 3 units. In the 5 unit, T1 has to execute 2 unit, and in the 10 unit, T2 has to execute 2 unit. This units has came from the given the given data. Means this is the from this row, from this column. So the advantage of this is it is easy to implement, and the disadvantage may be considered that when new tasks added, then the deadline differ, and we have to change our algorithms techniques. So I have done its coding in Python. So this is basically the code. So I have imported these libraries like the JSON copy and so on. So let me show you the my result. So first of all, it will let me zoom it a little bit. So first of all, it will ask the user the number of tasks. So let me take an example with 3. Enter the period of task T0. Let it be 20. Let the capacity of task T0 be 3. Let the period of T1 be 5. Let the capacity be 3. Let the capacity be 2. Let the period of T2 be 10, and let the capacity of this would be 2. So scheduling of 3 tasks means we have successfully scheduled this 3 algorithm. We can check that here. What is the condition? Checking condition is 0.77 and utilization is 0.75. Since the utilization factor is less than the checking condition, our algorithm can be schedulable by the rate monitoring scheduling. So this basically shows the interval in which the task can be scheduled, in which task is running at which interval. So this is the thing. Also, I have plotted the plot for the same. So let me show the plot. Let me undock it for better view. Okay, so as you've seen that the task T1 has the highest priority, it has been executed first. So from 0 to 2 units, since there are 2 units of it, it has executed in the first 2 interval. Then the task 2 has the highest next higher priority, so it is executed next. Then the task 0 has been executed. After that, five time interval, since the time period of T1 was for 5 seconds, then the next unit will be should be of the task T1. So T1 would be executed for 2 units, then task 2 should execute, but the task 2 has completed its required work, so it will not be executed, and task 0 will be executed. So this is how it's going to work in the how this is going to rate monitoring scheduling will work. In the 9 to 10 period, you can see that no task is been working and the CPU is in the ideal state since all the tasks has been completed. So this is how it works. And as you will see in the full 20 period, task 0 will execute only 3 unit. Task 2 in 0 to 10 period, task 2 will execute 2 units, and in 0 to 5 unit, task 1 will execute the 2 unit. So this is was basically was the given data which was asked by the which we have given in the algorithm. So this is basically the rate monitoring scheduling, which is highly be used in Micrium OS. So this is the end of my presentation. So thank you.